Hi everyone. Today we are talking about an interesting way of understanding how the computers work. So you can see computers as a simple robot, which is a very primitive robot, which only knows to serve what you say. It's a very obedient servant. Okay. So all that it takes is it takes an instruction, and it takes one instruction at a time, and it takes the data that you need for that instruction. So give that it an instruction and data and ask it to execute. So the moment you ask it to execute, it executes it and stores the results with it. Okay. So we'll give an example how it does with an add example. So let's say we are talking about an add operation and we want to add 6 with 7. So we gave it an instruction add with its inputs are 6 and 7, and now we'll ask it to execute. So once it executes, it correctly sums it up and stores with it as 13. We'll take another example. We'll take 13 as the first input, 22 as the second input, ask this guy to execute. This guy results correctly 35. We'll take a subtraction example. We'll give it 25 as the first input, 15 as second, ask this guy to execute, correctly gives us 10. Similarly, another subtraction, and 123 first one, 546 is the second one. We'll ask this guy to execute, and this gets us 423 minus. But this isn't very interesting. I mean, so what? Even a simple calculator does that same thing. The most valuable thing of, or the most interesting thing about this computers is it can chain. So it can chain various operations and then you can repeat them again and again. So for example, we're talking about a simple example. Let's say there's a guy called Maya. He got rupees 100 from her mother and he bought a banana for rupees 6. So which left 94 rupees with him. Then one of his friends Suman borrowed rupees 50 from him, and that left 44 rupees with him. Now there was a agreement between Suman and Mayank that Suman would return 1 rupee extra for every 10 rupees of per day of the per day of delay in the return. So, and he returned the money to Mayank after 7 days. So in total he returned 50 divided by 10 multiplied by 7 because there was delay of 7 days, and plus the original amount that he borrowed, so 85 rupees. So 85 rupees he returned. So in total the Mayank got 85 plus 44 is equal to 129. And we'll now see how we can do it with the help of computers. Right? But before we get into the computer program, we'll try to understand how would this work when we use a computer. So once again, our friend, which is an obedient friend, computer is here, and it's like a robot. As we said earlier, it's going to do what we want it to do. So initially what we did, we just asked, we want Mayank's to have rupees 100. We said Mayank's money is equal to 100. So the moment we say that, there's something called memory in which we have an area which we designated as Mayank memory, and we have a value 100 stored here. Then he bought a banana for rupees 6, and that's once again uh, we took one piece of memory which we designated as price of banana and stored 6 there. Now the third step is that Mayank has to buy the banana. So the moment the Mayank buys the banana, so Mayank should be remained with lesser money, and let's see how it happens and how this computer does this calculation. So what really happened is we called something called a memory manager or transporter. So this guy would copy what we had with Mayank, kind of, so it can kind of take a photo from here and give it to this computer and serve as a data of the instruction, right? And the second thing it copies is the 6 rupees of the banana price and copies here, and then it, because we need to subtract This guy says subtract and issues a command to execute, which returns 94, and this 94 once again is taken back and stored here in this memory. So now Mayank has left with 94 rupees. On similar lines, when Suman borrowed 50 rupees, so we acquired another memory where we stored rupees 50 and the number 50, and then in the next step, now we'll see how much money Mayank has left with. So now Mayank would be left with the money that he had earlier minus the money that Suman borrowed from him. Okay, let's see how this computer works. So once again, this guy is going to first of all take Mayank's money, takes from here, copy to the in the first place, take the Suman borrowed from here to here, and do subtraction operation and when store the results here. Let's see, and the output would be actually stored in the Mayank's money. Let's see. So this guy started, copied this 94 here, copied this 50 here, set the subtraction operation, executed it, and computer executed it, and the results 44 got stored with the computer only. Now this guy would take this 44, copy it over to Mayank's money. So this 44 is copied over there. Okay. Now next thing is we need to return for each day. Suman has to return some amount. So let's calculate how much that amount is. Suman has to return each day is equal to how much he borrowed divided by 10. Okay, so let's once again see what that's where, because there are calculations involved, and that's where the role of this computer or this processor comes. And see what happens. This Suman borrowed. So Suman borrowed is copied from here to here, which is 50, which has to be divided by 10. So this 10 is copied here. The operation is division. Now the moment we ask this guy to calculate, this guy calculates 5, and we store it into a new memory location designated as Suman to return each day. This guy does that, and you have a variable, or you call it the memory location, which is designated by this name, and we have value 5 here. Next step is the days to return. So we have another memory location, we set it to 7. Next thing is extra return, which is the amount of money that Suman is going to return extra because of this guy has borrowed for 7 days. So which has to be equal to the amount that he has to return per day multiplied by days to return. So 5 multiplied by 7. Let's see what happens. So Suman to return each day is going to be copied from here to here. Days to return copied from here to here. The operation is multiplication. It gets executed, it gets 35, and this 35 it gets returned in extra return. So we got a new memory location which is extra return, and that's where we are storing 35. Now the next part is how much total has to be returned. So total return is equal to Suman borrowed plus extra return. So Suman borrowed is 50, so this 50 plus 35, let's see where it goes. So this 50 gets copied here, this 35 gets copied here, operation is sum, which is addition, it gets executed, we get the sum here, and this value total return gets created here. Okay, now total return plus Mayank money makes the total amount with Mayank. So that's where we go. So which is Mayank's money plus total returns. Once again similar things. So Mayank's money would be copied here, which is from 44 bit copied here. Total return 85 would be copied here. Operation is add. Executing it gives us 129, and this 129, because this 129 gets stored to Mayank's money, so this guy once again takes it back, copies from here to here. You can see it. So that's what this interesting thing is, and we let the computer do it through a programming language. There are many of them. We can use any of the language. For this particular sample or example, we are doing it one in Java. So this is a piece of code which is, if you see, this exactly matches, almost exactly matches with the with what we were seeing earlier. So we had like Mayank's money, price of banana. Mayank's money we are calculating with minus price of banana, what how much Suman borrowed, and how much left with Mayank, and then how much Suman has to return each day, how many days to return, and how much extra was returned, what was the total return amount, and what was the total amount with Mayank. So it's exactly the same that the way we did it in our we call that algorithm. And we have this there are two different things which you can see here. One is the system.out.println. So they are different because everything is happening inside the computer. We need some way to see the results. So we have the input output libraries. Different languages have different libraries. So for Java, for the command line we have system.out.println command. So as you get to know a language better, you have many more constructs to learn. But in principle, everything is similar. So we are simply saying, like, we are talking about Mayank's money. We are saying we need to print Mayank's money, and which is as simple as a string, and then we are talking about how much value we have in this Mayank's money. Okay, so in this particular example, which is matching with what we had in the earlier sections, so the same numbers are here. So we expect the same value, which is 129. So once we execute it, which is because the Java command, so once again you compile. So each language has a certain way of executing and building their program. So depending on the language, there would be different instructions, and depending on the tool, there would be different way of executing it. But in principle, everything is same. And then you execute it. So once you execute, you get this 129 exactly matching with what we were doing, right? So once again, in this case, we had all these variables. So this int Mayank money that got created here, price of banana here, Suman borrowed here, and similarly others. It's a very simple thing. If we can do it manually, and if we can do it logically, without a computer, we certainly can do it with a computer. And most interestingly, I didn't even use any kind of special software. We just used one of the compiler freely available online. So like even it's like even if you do not have a computer, you just have a tablet. I mean, you simply can use a tablet, go to any of the online compilers and try out the stuff. It's going to be very easy to work with, and depending on different languages, you may need to read different books to understand syntax, but in principle, the logic would remain the same. So this um, this is somewhat interesting though, but may not be absolutely interesting. But where the magic comes is, what if this guy Suman, he borrowed, instead of rupees 50, they borrowed rupees 80, and instead of 7 days, he borrowed it for 12 days. So how much the money would Mayank have finally? So once again, there are so many calculations to be done, and this is what we can simplify using the computers, right? So all that we did now, whatever we were doing in that specific function, we actually there's a concept of compiling the same things, or reorganizing the code that we were having earlier to into smaller functions. So this kind of building building higher level of machines. So for example, if there's something which requires two add operations and one subtraction, three multiplications, so instead of remembering to do all of them, we can just create one automated stuff which we call functions, and even if provided with right inputs, it would do all those operations for you. So once again, as you can see, we kind of made this function take the money, initial money that the person has, the price of banana, and how much the borrowing, and how many days of return are there. So because these are the only things which are varying, and using all these four, we exactly have the same calculation that we having earlier. It's just kind of extracted in from the previous function. And this is a function which is returning the calculated amount, which is the Mayank's money here. Okay, and we can absolutely call it in various ways. So in one example, you see 100, 6, 50, and 7, which is my memory 100, price of banana 6, so it borrowed was 50, and days to return was 7. All that we did was, it's like a machine now. In this machine, we kind of provided this input, and the machine gave us an output. Once again, we stored that output in this variable, as we were showing those memories blocks in the previous slides. And similarly, all that we did, we now use my money to 100 rupees. We changed to 80, the borrowing of 80 rupees, and then we changed the days from 7 to 12. And it's just very simple, quite easily. It can be easily read. And once again, calling this function, we got the newer amount. And when we execute it, we see in the first case 129 is expected, and in the second case 190 as expected. So you see, once we remember, once we codify, once we let the computer know the logic, I mean, you just don't need to remember, and you can trust computer to do it the same way again and again. So this is how we build interesting things. We build from smaller things, we keep compiling from smaller things, and as we keep adding layers and layers and layers, we start building complex solutions. Okay, going back to the new stuff, where we, as we go ahead and create more solutions which are further complex, we have relational operators, we have loops, we have modules, we I mean, of course, we just talked about the functions. There would be complexity around the designs, there would be complexity around system architecture, but we do not have to learn all these things in one single go. As we keep incrementally learning more and more things and fundamental pieces, and we become comfortable with them and how to use them, then they can be used in many different ways to create solutions to solve complex problems. So they may look very complex, but everything starts small, and we just need to focus on building the strength on smaller pieces, using them, being very sure what they do and where they're applied, and apply them in right places can give us good solutions. So that's really it, and I hope you enjoyed it. For many more videos, you can actually go to our YouTube channel. You can access our YouTube channel from our website. So that's it for now, and we'll share with many interesting videos in the future. Hope, thanks for listening. Have a good day. Bye.